This is a nice small group, so I think we can be very informal. And we're going to talk about one of my favorite materials. Normally in preservation school, they ask me to do the impossible, which is to talk about all sorts of, and Susan, you've been through that, right? All sorts of...
Every material, yes.
Not every, but a lot of historic materials. So usually the bag of rocks that I bring down to this includes brownstone and slate and sheet metal and all sorts of things that you'd find on a historic building. But this year is kind of the year of terracotta, which is wonderful. Great for me, great for HDC, and I think great for the city and the preservation community as a whole to celebrate this wonderful material. So I'm going to talk a little bit about the basics. I always believe very strongly that those of us who are practitioners and those of us who study the material science also should understand the why, the social reasons, the cultural reasons, the historic reasons why something works, doesn't work, why something's popular, why something comes into fashion, goes out of fashion. And terracotta is really a wonderful example of that. Now let's start by asking the group here, has anybody ever made anything out of clay? Pottery class, anything like that, ceramics?
How far back can we go?
You can go all the way back, Susan. Pinch pots, ashtrays? Yes, okay. All right, so that's basically the idea. The idea is that architectural terracotta is like any other ceramic. It's a clay body that is formed either glazed, slip-coated, and we'll talk about what that means, or unglazed into a desired form, then allowed to dry, and then fired. And the basics are really very simple. There are only really two components of a piece of terracotta. If you want to pick up that ugly chunk there, that's from 960 Park Avenue, and look at it closely, you're looking at a piece of mortar with a rust stain on it. We'll talk a little about why that's important. But also you're looking at the body of the terracotta, and look closely at that, and you'll see lots of little white flecks in the body of the mix. Right? Do you see those? They're white and they're off color. What you're looking at are really the two basic components that make terracotta work. One of them is unfired clay that gets fired as part of the process, and the other is usually previously fired clay, which is called temper or grog. And I always like to use the analogy that temper or grog, which is mixed in and can be up to 25 to 30% of the body mixed in, is previously fired clay. So it's like having a grown-up in the room that's seen the horror film before you. So you don't get quite so scared, so you don't freak out. So what that does is that's very, very stable material that's already been fired that keeps the rest of the body from warping or distorting as it goes through the process that really sets terracotta aside from any other architectural material, except for brick, perhaps. And that's a process that we colloquially call sintering. And it's very complicated, but the basic idea is that the piece of clay and its previously fired material is allowed to dry completely, so there's no water in it. And it is fired usually to about 1200 degrees centigrade, which is incredibly hot. And in that firing process, the clay body, which is basically an alkali silica, goes from being one type of material to another, and that change is irreversible. And that sintering can be sort of simply referred to as a partial transition into glass. Right?
Partial transition
into glass. So we're firing it, and we're allowing the materials to meld together under incredible heat. And if it all works out well, and it doesn't always work out well, once everything cools back down, it is now a fired ceramic material, which means we can put it in water and it will not dissolve. We can put it in acid. Come on in. That's all right. We can do nearly anything to it, which is what is among the wonderful things about the material is that it is, unlike various natural stones, it's relatively acid insensitive, which is important still in our environment, even though we don't burn coal anymore here in New York. We now still have a fair amount of acid from truck exhaust, because New York City, people were talking about good city planning earlier, has yet to figure out how to bring so much as an apple into town on a train. Everything still comes in through trucks. We don't even use boats to bring our fish in anymore. So all that exhaust is out there in the atmosphere, and it's still causing a lot of acid. So unlike the material that it often is designed to look like, which is limestone, terracotta is relatively acid insensitive, which means that it's easy to spot. So let's talk about spotting terracotta. And I hope people come out of this looking up, because mostly you have to look up to see it, and understanding that a lot of what you may have thought was natural stone is probably terracotta. So these guys are a good place to start. This is from the book published a number of years ago by Gladding McBean, who are one of our landmark lions this year. They are a company that has survived tenaciously in Lincoln, California since the glory days of terracotta. They survived through lean years by extruding sewer pipe and by doing anything else they could do with clay. They actually made some lovely ceramics in the mid-20th century. But these guys are here sort of during the heyday of terracotta production, and they have just tipped this lion's head out of a plaster mold. And they're about ready to clean out the mold, and the lion's head will be sent off to dry and to have its moisture leave it. So it may be glazed or it may be unglazed, and then it will eventually be fired. This is about the biggest piece of terracotta that you will see in the field, even here in New York or really anywhere. And that's one of the things that sets terracotta, let's see if I can do this, sets terracotta aside. Here's the Woolworth Building, right? Always a good place to start. A couple of years ago, 2013 was the centennial of the Woolworth Building, and there was a terrific exhibit called The Largest of the Handmade Buildings. And it's a remarkable moment in architectural history here in the United States, because it's Cass Gilbert, who loved terracotta and went on to do a number of other, we'll see another late Cass Gilbert building later on. You know, I don't have to talk as fast as I normally do, because I don't have 14 other materials to go through. So I'm going to slow down a little bit. And there are, as part of the exhibit, there are a number of photographs. And one of the photographs was a photograph during construction of the building in the background with its state-of-the-art 1912 steel frame. Right? An unimaginable thing in terms of building in New York City at that point. Not unimaginable, but pretty new, pretty damn new. And in the foreground are horses and wagons that are delivering terracotta that has come across New York Harbor from Perth Amboy, which is really the center of terracotta manufacturing in our part of the country, on barges, has been picked up at the wharfs by the preferred mode of transportation at that time, which is a horse and wagon. So the most modern building in the world, arguably the most modern building in the world, is being built with a material that is hand-pressed into molds that were handmade and delivered by horses. So it's a wonderful paradoxical material. It's mass-produced, but handmade. Yep.
Is all terracotta made in molds?
We will talk about that as we go on into the process a little bit.
Is it liquid when it goes into?
We'll talk about that too.
Pressed.
Yep, we'll talk about it. In fact, we have some good slides showing exactly how that's done. So one of the things that's a tip-off when you're looking at a building, first, let's think about, other than the Woolworth Building, there's a kind of classic New York City apartment building cocktail, let's see, which is, oops, right, hold on. This is a Beehive Kiln. So this is one of the factors that limits how big a piece of terracotta can be. So one of the things that's a dead giveaway is size, lots of relatively small pieces of masonry. If I have grand designs, if I'm Charles Fallon McKim and I want to build an instructional building up at Columbia on the new Morningside Heights campus, and I want those columns at Barnard to be one piece of limestone, if I have enough manpower, person power, train power, haulage, the ability to lift that thing up straight, I can make that out of one big piece of stone. That's never the case with terracotta. So one of the things you should look for when you're looking to determine if, hey, is that a limestone building or a terracotta building? What is that? Is size. Lots of small, repetitive pieces. And sometimes that in itself was a remarkable challenge to the terracotta manufacturers and to the people that made all this work, the builders and the architects, was how to make those joints disappear, how to make it look more like, in the early days, more like a traditional building, and then later, as we get to things like the Chainin building at 42nd Street, how to just let loose and realize that, holy cow, I don't need to have this thing look like traditional masonry. It doesn't have to look like it's stacked one piece on top of another, and we'll see that when we get to 36 Gramercy Park East. I can have this thing hung on a frame, like the Reliance building in Chicago. I can do, at a certain point, nearly anything I want. And I can defy gravity with the stuff. And I can build from bottom to top or top to bottom, unlike the traditional way that I build a brick building or a tenement or almost anything that's been built up to this point. So here's one of the limiting factors and one of the ways that you as sort of people who are now sensitized and fascinated with architectural terracotta can walk around town and figure out whether you're looking at a terracotta building or a stone building is size and repetition. Lots of fluid details that would be very, very difficult and very, very expensive to do in limestone, for example, are no problem in terracotta, and we'll see why that's the case. So size is one thing. The other thing that you're looking for when you look for a piece of terracotta is homogeneity. So a piece of limestone, and I use limestone because limestone, Susan Tunick, who's another one of our landmark line, and I have a sort of ongoing discussion about how much terracotta in New York City, because this is really our turf, is designed to look like limestone, and how much terracotta is designed to look like anything else, whether it be terracotta that's immediately recognizable as terracotta. I think it's about 80%. She's a little bit, she goes with a little lower percentage. But in my experience working on buildings in New York City, the acres and acres of fired ceramic material that make New York City what it is, a lot of it is designed to look like limestone. So you've got size, but a piece of limestone is a piece of limestone from the very outer edge all the way back to the very back edge of it. It's homogeneous, it's unchanged. But if you look at this piece, and this piece, which actually is a glazed piece of terracotta from one of the White Sisters on the Upper West Side, and you'll see there's a difference between the coating on it. In this case, it's a vitreous glaze, so it's a glaze a little bit like porcelain or like a piece of china that you might have at home or a toilet bowl. But if you turn it on its side, you'll see that glaze is only a few microns thin. And the rest of it is a very boring buff-colored material, which is the terracotta. If you look at the back of that, you might see some finger marks. And those are finger marks of the people that pressed the terracotta by hand back, in this case, in about 1915. If you look at that piece there, you'll see that there's that there's a less exciting coating on the surface, but it's still different, and that's what's called a slip coating. Slip is what's used most of the time to imitate limestone. And what slip is another clay body that's liquefied and brushed or sprayed on the surface and then fired. So I can use the inexpensive, the common body that comes out of the clay pit in New Jersey, but I can put something on it that's permanent, pretty much permanent, and fired in place to make it look like limestone. So these guys are laying out an arch, which was common practice, because one of the other things that terracotta does is it deforms during the process. If I take a piece of limestone, I put it on my stoneworker's bench, and I carve it, and I'm good at it, and I'm good at carving, then I can produce the details that I want, and I know exactly what's going to happen. It's not going to change in size significantly. It's not going to change in weight. Nothing's going to happen to it through the process. Terracotta is very, very different. All hell can break loose in the process of making a piece of terracotta, not the least of which is warping in the kiln. So that's the other reason that we have a limitation in size.
Question, I mean, as far as imitating limestone, like it's a Grand Central where they have that imitation can on the walls.
Outside?
Can you explain to me the different, or explain to everybody, the interiors and exteriors in terms of use? Why the decisions are made to use terracotta?
Well, let's go forward, because I think that'll become pretty obvious to you once we go into the process. This is a man who's making a new positive up at Boston Valley Terracotta. This is one of the, it's not a gargoyle because it doesn't spit water. We're not allowed to spit water in New York City. But this is at, do you know 36 Gramercy Park East? It's the building with the two sets of suits of armor in the forecourt. So we did a major restoration there in 2015. And this is someone recreating a new piece of terracotta. So this is to take you through the process of why it's different than stone and why you might choose it. Hey, come on in. You haven't missed much. So this is sort of a nice blend of old and new technology. So what we have is we have the original piece of terracotta that's been taken off the building and transported up to Orchard Park, just outside of Buffalo. And in this case, a sculptor is making a new positive. The new positive for the plinth, which is the architectural element that the creature is leaping from was made using computer-assisted drafting and a multi-point drill thing, which has revolutionized our industry. And there's a terrific secret about terracotta that requires this sort of level of craftsmanship. It's one of the things that has made it difficult for us to reestablish a good terracotta industry in the United States is every time you make a new piece of terracotta, you can't just make the new piece of terracotta. You have to make a new positive that is 1 inch larger per foot than the original. Then you have to make a mold. We'll see some of the molds in a minute. And then you have to make the actual piece. So the piece starts out its life as wet, uncured clay that is slugged into the mold, still often by fist today, although there are other methods which we'll look at. And it starts out as this object that is 1 inch larger per foot, about 12%. And first it dries, so we put it in a dryer, and it shrinks a little bit. And then once it's dry enough, we can glaze it, treat it however we want, or leave it unglazed. And then it goes into the kiln, and it shrinks some more. The great trick about terracotta is, can I get it predictably and consistently back to the right size? This is important in new construction, but it's wildly important in what I do, which is restoration. Because if I take a piece of terracotta out, I need to have the new piece that is exactly the right size. So terracotta manufacturers, they use all sorts of tricks and techniques to make sure that they can create things that come back to the right size. Now, if they mess up, which happens all the time, then guess what happens to that piece of terracotta that's the wrong size? It gets tossed out in the back, and then it's put in a grinder, and it's ground up, and it becomes that stuff we talked about at the very beginning, which is grog, right? So it doesn't get wasted. I was at one of these interminable architecture shows a couple of years ago at the time when there was a terrific amount of what we like to refer to as greenwashing, where things are made to appear more environmentally friendly than they are. And there was a manufacturer of quarry tile, which is the stuff you see on institutional kitchen floors, which is basically terracotta. And he said, do you know that up to 30% of our tile is recycled material? To which I responded, of course it is. Because if it wasn't, it would explode in the kiln. Right? And then up to 100% of your kilns would be full of overfired glassy garbage. Right. So anyways, so yes, it comes. So this is what's called a terracotta ruler. So he's comparing it to a regular ruler. If you could see, if it was a better slide, you could see that the inches are just a little bit bigger. So the terracotta industry, when it was in its heyday in the teens and 1800s, late 1800s, teens and 20s, employed lots of people of all levels. And if you get interested in this stuff, a great field trip is to go out to Alpine Cemetery in Perth Amboy, New Jersey, where I don't have any slides of it in this lecture, but where the great terracotta factories were. And there was a culture out there of producing terracotta gravestones and terracotta mausoleums, which you don't really see in other parts of the country. And the great thing about it is they're all levels, from very fancy graves that were clearly commissioned by someone and created professionally, to someone who just stayed after work and made a grave for a loved one that passed away. So all those people, and a very large immigrant community, there's some fascinating literature on the subject, lots of Germans, lots of Irish, lots of Italians, came over, and there was all levels of work that you could do, from being the guy who slugged the clay, right? Probably the lowest level was a presser, to someone who was a sculptor, who actually made the positives, to mold maker, which is what I started my life as, to a kiln master, someone who controlled the heating, because it's very, very complicated. And there are different ways of heating and cooling to get the effects that you want. To draftsmen, lots of people who just drew, because all this stuff had to be put together and numbered, and we'll see a little bit of that. So here I have an original piece, and I have a new positive. And if you look, you can see that the new positive is slightly larger. So that once I make my mold, I can bring it all back down through drying first and then firing to the same size.
So my question is, now when you make your positive, why don't you just use it to a computer?
We do.
You can,
sometimes we do.
You know, it's computer.
Sometimes.
Simply
when that,
3D printing, essentially.
some of it is done that way. And It used to be that people had to use calipers. When I started, we used calipers, we used terracotta rulers, we used all sorts of things, and we had to be very careful to upsize and then make sure everything got back down. Now, some of that work can be done by punching a number into a computer. So, for example, we'll see some slides. These are molds. And there's a fellow pressing in the background. So he's throwing the clay in, the wet clay. Now, for example, the Terracotta company that was north of Manchester, which went out of business, is coming back. Shaw's of Darwin, it was called. Now I think it's called Shaw's Terracotta. They have a very good laboratory. All the manufacturers have a very good laboratory, and they do either every other day or every 3 days, they do a firing and shrinkage test so they can keep up with whatever their current clay body is. And that informs everything they do. From the moment they wake up to the moment they go to bed. They are punching in to adjust their drawings, they're punching in to adjust their computer-generated machines, and they're informing their mold makers. So yes, a lot of it now can be done. Not everything. But we also now get computer-generated shop drawings. So we as architects can evaluate the pieces more in the round as opposed to just, the old-fashioned way of drawing by hand. So here's a press of the pressing room at Boston Valley, and what you're seeing here are the molds. So this is the next step. So now I've made my positive, and now I'm going to make a box mold around that positive, which is basically a shoebox of the right shape, and it's made of pottery plaster. And it takes advantage of one of the great things about working with clay and plaster, which is there is a natural affinity between the two materials. They simply will not stick to each other. So I'm able to, and what this young man is doing is he's whacking that clay into that mold. I'm able to put the clay in without any sort of release agent. Anybody who's ever done any casting or anything, you know that you've got to grease everything up and got to make sure that if you're, for example, you're casting a piece of concrete, that the formwork comes away and doesn't stick. In this case, it's perfect. Pottery plaster and wet clay will separate naturally because the pottery plaster draws just enough water out of the clay, which is a great thing if what you really want is incredibly sharp detail, which we can get. If you think of those, of the Guarantee Building in Buffalo or the wonderful Louis Sullivan building down here, Bayard Condit building, look at the detail there. It's astounding. And the technical reason that that detail is possible is not just the gifted work of the sculptors and the people who made the mold. It's the fact that the fidelity of the detail is tremendous. And I teach this at Columbia, and every year the students press a couple of pieces of terracotta, and it's uniformly astounding. And we have a Louis Sullivan-inspired mold that we use, and all of those little leaves come out just perfectly. So this is a piece, 436 Gramercy Park, that's been tipped out of the mold. I say perfect, it's never perfect to begin with. There's usually a little finishing that can be done with a sponge and water to make sure that there is a little bit of air pockets or bug holes, that those get smoothed out and the piece is as we want it. And the great thing about terracotta is, remember we talked about it at the very beginning, until I fire the thing, I can reverse it completely. I could put that piece of clay into a bucket of water and it would gradually break itself back down and I could reuse it. Once it's fired, I can't do anything to it. So until the time it's fired, I can finish it, I can clean it up, I can make it as beautiful as I want to make it. I can do additional handwork. So I can overcome the limitations of mold making. Mold making is limited always by the process, by something that's called an undercut. If I have something that goes around underneath, I can't pull the mold off cleanly, right? But if I want to then go in and create by hand that undercut, perhaps to get a deeper shadow line or something that's more interesting on the facade, there's nothing that keeps me from doing that other than the cost of hiring someone to do that. So why am I using terracotta as opposed to cut stone? This is why. Because it's so easy to use and it's so repetitive. I can get, these guys are really good, it's really high quality stuff, so they don't reuse a mold more than probably about 15 times, maybe 20 times. But if I want to really just keep going, I can keep pushing and pushing and pushing into these plaster box mold and keep getting the same piece identically each time, finishing it, drying it, and firing it. If you think about doing that in a piece of brownstone or doing that in a piece of limestone, think of the difference in labor in doing that. So I always say, and I'm going to say this at the Lion, so you get the Lion first now, is that terracotta represents a democratization of ornament. It represents an ability for particularly cities like ours in New York to reach for ornament that had been the province of just the rich before that. And if you walk around, one great neighborhood to walk around is the Garment Center. The Garment Center, if you read Andrew Dolkart's book, is an instant factory district. It's because they no longer wanted people to make clothes close to the Fifth Avenue stores. So they pushed them all over. And in about 15 minutes, they needed to make a whole series of new vertical factories in New York City. And they turned to terracotta. They turned to some of the best architects in New York, like Schwartz and Gross. But they turned to this material, which was repetitive, fireproof, right? Because you don't, after the Triangle Shirtwaist Fire, we don't want a non-fireproof factory. And you can make it beautiful. So even on those buildings, which are among the simplest buildings of the 19-teens and 20s, there's a terrific amount of ornament. There are glaze effects that are just gorgeous on those buildings. And it's all because of this egalitarian material that allows us to do something that previously it took someone days, a highly skilled craftsman, days on a stone bench to produce. So this is another type of casting. Who was it that asked about liquid? Was it you? Okay, so this is in England, and they do a different form of casting, which I won't go into a great deal of detail about. This is called slip casting. Has no relation basically to the slip coating that we talked about. But this uses a fully enclosed mold, as opposed to a shoebox mold that's open at the top that I bang into with my hands. And I pour a liquefied clay into this, and it's much more akin to casting metal. So it's a little bit like casting bronze. I need a port for the clay to go in, and I need a vent for the air to go out. And once the mold is entirely filled, then the clay starts to set up, and I can dismantle it just like a regular pressed mold. So this is slip casting. If you've ever, back in the day, you used to buy tomato juice in cans or pineapple juice in cans, and you couldn't just open one side, it wouldn't come out, right? You had to open both sides. So you needed a port and a vent. You needed to get the damn juice out, and you needed to let the air out too. So two of these are ports and two of these are vents. It's a great process. The mold making is much more complicated because it has to be a fully enclosed mold. But the casting is incredibly simple. This guy just moves this hopper on a gurney system around, and he just pours clay all day. And then they go home, and the next morning, it's ready to take it apart, set it up, and head off to the finishing room. So here's a little example of some of the drawing. This is actually pretty promotional, but it's similar to what you would see. And it's part of the terracotta industry's effort to make terracotta the go-to material for any type of building. So you don't need a fancy building. You might be just building this office block somewhere. But what you're seeing here is a section. People know a little bit of architectural terminology. A section is if I slice right through a building, and I'm looking at it as if I've sliced it and opened it up. So here I see that terracotta is a hollow-shelled material. In this case, it's backed with brick, and I see lots of things starting to creep in, which are those dark shapes, and those are metal or ferrous anchors. And if you look at the little piece there, you'll see that there's a dark stain on it. Most of the time, when we look at terracotta buildings that are in trouble, here's a nice storefront, we're not looking at a fault of the terracotta itself, we're looking at a fault of the substructure, what's holding it to the building. And that's often uncoated iron or steel. And of course, the assumption was, look at all that steel, and look how close to the surface it starts to get in the 1920s. The assumption was that terracotta, it's glazed, it's impervious to water. Nothing in this world is impervious to water. And so once the steel starts to corrode, it's surrounded by a dense, brittle material, which without the steel would do just fine for another 100 years. But then it starts to what we refer to as spall. It starts to send pieces down into the street. And that's the cause of the local law that came to effect in 1980 when the young woman was killed up at Columbia, and has basically been the catalyst for the renewal of the restoration industry. It's basically what I owe my career to, and a lot of us do, and what Boston Valley and Gladding McBean owe the resurgence of the terracotta industry to is this law that was passed to protect the public. So terracotta has a bad name in terms of public safety, and we have to be very careful about how we treat it. This is a wonderful building and gives you an idea of another reason why you might turn to terracotta. This is now called the Cass Gilbert. It's 130 West 30th Street, right next to the police station. We worked on this building a number of years ago. It's very late in Cass Gilbert's career, and we used to have a fight with Francoise Bollock because she didn't like this building very much. She sort of claimed that he was just picking up a paycheck, but I argue differently. I think this was genius. He's using a buff-colored brick, and then he's using probably about a dozen molds to do this entire Assyrian-inspired frieze that runs around the building at various levels. So this is what it looks like up close. This is from promotional material from the Atlantic Terracotta Company. Their showroom is New York City, but all the clay is made in Perth Amboy and South Amboy. And you can see the genius here. Look at the band that runs around. That's 2 molds made into a repeat pattern. There's a corner, which is flipped as I need it, and then there's a running band. And it's all made so it lines up beautifully. So when you're standing on 30th Street, it's a continuous band. You don't really see those joints. There's a right-handed winged lion and a left-handed winged lion. There's a right-handed sphinx and a left-handed sphinx. And then in the middle, just for the sheer joy of it, there's this sort of potted plant that whips along. And for next to no money, he's created this great visual interest on a building that was basically designed for fur storage. So this is it in modern day, and you can see it's got a lovely color to it too. It's got 2 colors. So he's not just using an economy of molds, an economy of material, but he's also using an economy of finish. Because when we get close to this thing, we see that, Susan Tunick and I talk about this all the time. She claims that that's a beige slip coat for the background. I think it might actually be just the color of the Atlantic Terracotta body. Just using the color of the body and then picking out the figures in this light cream colored glaze. So again, he's not going to the bank very often for this, but he's getting a terrific amount of visual interest. So that's one of the reasons why I would turn to terracotta. I want repetitive ornament. I want something that I can use even on a building that is not the fanciest building. And this certainly is not a fancy, now it is. Incredibly wealthy people live there, but that's New York City. This is the last project which I want to talk about. And someone asked me, is all terracotta pressed? And the answer is no. Basically, the ways that we can make terracotta into the form that we want it is by pressing, which is still the majority of what we do here in the United States, slip casting, which we saw in those fully enclosed molds with liquid, something that's pretty rarely done, ram pressing, which is exactly what it sounds like. It's a hydraulic press, and there's a mother mold and a baby mold, and a slug of clay is put in, and the hydraulic press comes down and stamps it out. That's for a lot of simple, repetitive things. And then the last, which is a technology that's being used more and more, and which is great because we can, if we have enough of these pieces, we can save the building owners a lot of money and get the real stuff, is extrusion. So we're looking at 3 pieces here for 111 Hicks. 111 Hicks is the old St. George Hotel. Used to be the tallest hotel in Brooklyn. It used to have the largest saltwater swimming pool in North America, and it had the distinction of having the guy who played Tarzan swim there every morning, Johnny Weissmuller. So the 2 pieces that you see there on the left, the blue and white and the white, are extruded, which means the best way to describe it is if you've ever used a pasta machine and you put in the little die. If you want rigatoni, you put in the rigatoni die. If you want spaghetti, you put in spaghetti die. And you push the dough through, and whatever shape the die is, out comes the pasta in the shape that you want it. That, on a much larger and more industrial scale, is what extruding terracotta is. So I'm using a clay body that's a little more dense than the hand-pressed body, because it's got to stay straight as it comes out, and I'm pushing it through a die under tremendous force. The piece on the right is hand-pressed, and there's a very good reason why the piece on the right is hand-pressed and not extruded, and that is extrusion has a very severe limitation, which is that the piece that you're extruding, because it's going through one die, it has to have the same footprint at the beginning as it does at the end. I can't flare, I can't make any detail to it. So those pieces, they're actually the exact same die, they're just treated differently with glazes, we were able to extrude those. So this is the building. This is a very fun project. And it's, I don't know, did someone recognize this 111 Hicks? Do you live there?
I live at 108.
108, so you know.
This is right.
So it's a great building.
All in sunlight.
It's Emory Roth, yes, but it has since 1929. So it's Emory Roth and Sons. And if you look, you can you go to the building and you look, and we went to the building when we first got started. And there are these little bumps up on the 29th floor setback. You can see them on the left there, up against the sky. And when you get up there they are. And what are those things? Are they chimneys? People don't just put stuff up for no reason. There's the view from up there, and that starts to explain what these things are. There they are when we first got there, and of course, you're never called in because the owner of the building has an aesthetic complaint about the terracotta. It's almost always because the damn thing leaks, right? So the damn thing's leaked, and the superintendent decided to take heavy-duty trash bags and wrap them, which didn't really help, Christo style. But he didn't just wrap them, and this is what we've always been amazed by. He insulated them. And I don't know, I never understood what this is doing. But here are the things. And they're beautiful. They're these kind of Dr. Seuss-like things. They've got a round shaft, and then they've got this yellow and green thing that flares out at the top. And what are they, and why are they there? Well, the solution is really pretty simple and pretty ingenious. They're there because the people who commissioned Emory Roth to design the building were right in the middle of the jazz age, and they wanted a rooftop terrace restaurant and jazz club. And who wouldn't with that view, right? So, but they had a problem. With hotels come thousands of bathrooms, lines of bathrooms, one for each room. And for each line of bathrooms, you need the nasty little thing that's contained in the middle of this, which is a vent stack. If you've ever been up on the roof of an apartment building in New York, there are scattered around these 4-inch utilitarian cast iron pipes. They're ugly, and they stink. There's really nothing pleasant about them. So he decides that he's not going to let all of those get in the way of his restaurant, and instead, he's going to make them into a feature. Genius. So he builds these things, and so our task was to restore these things. The building is, I believe, an individually designated landmark, and so the Landmarks Commission wanted us to salvage as much as possible. Because again, the problem wasn't with the terracotta, the problem was that the whole system leaked. Terracotta, most of it was fine. We were able to save about 35% of the original pieces. So these are color samples from that project, if you want to pass them around. This is glazed terracotta, so it's receiving a vitreous glaze, just like a piece of porcelain or a ceramic that you might eat off of. And so we've got new pieces, and there are the old pieces you can tell because they've got a little bit of dirt that's crept up underneath the glaze down at the bottom of them. But the commission wanted us to, and we agreed that we would put the reconstructed originals up at the front of the building, and at the back of the building where they were less visible from the street, that's where all the new material would go. And they really live quite well together. There's an original piece. So there's been some fading in the glazing. There's a little transparency to the glaze. But it's basically in pretty good shape. So all the pieces were originally hand-pressed, but these pieces, which have the same footprint from top to bottom, could all be done with an extrusion. So we saved the owner a terrific amount of money. The only downside to extrusion is that sometimes it's too perfect. So the firing process of a hand-pressed piece tends to lead to a little bit of waviness in the wall. And the machine process of extruding can lead to a piece, if you set it in the middle of an otherwise historic wall, will stand out because it's too smooth. But this was not a problem. These things are in the round. So here's one that actually isn't a vent stack. It's being waterproofed with a resin-based material. The black stuff is temporary. But you can see this forest of vent stacks that are running around the space. Then the pieces start to go together, and we're 29 stories, so that's what, 290 feet above the East River. So these things have to be reinforced so they don't blow away. So there's a complex reinforcement that goes into them, but these are the extruded pieces, and you can see how simple they are. They're kind of wonderful, I think, because they're each the same, one die, one process, and we get the full, you can see a little bit of one in the distance there. With just that one process, we're able to build the entire drum of the column, And we use the same clay, the same extrusion, the same process, and we just glaze the striped ones differently.
Aren't they, the old ones, would they have been solid?
Well, you can,
Whereas those
no,
are hollow?
nothing is ever solid. So what you're looking at there, see next to the bucket, there's one of our new extruded pieces, and then there's a hand press piece right next to it, one of the flared pieces, and that's an old
They
one.
were not,
I can't make anything solid in clay for a couple of reasons. The most important is that I'm never going to get the water out of the center of a solid hunk of clay. I've always got to do it in usually about, and if you look, about this thickness, about 1.75 to 2 inches of wall thickness. Right? It's a little bit like a cinder block, so it always has cavities in it. It always has a center, and that's to make it lighter, because one of the, I mean, today you would not think of this as a lightweight building material, but back in the day, when it was new, it was billed as fireproof, which it was, lightweight, easy to erect, repetitive. All these things were selling points. And if you think about it, if you're a established architect or builder in, let's say, New York City in 1870, and this crazy, wild-eyed guy who has the really convenient name of James Taylor, who's considered the founder of American Terracotta, comes over from Stamford, England, and tells you, you're going to start building, you're going to love this material, you're going to start building with it, every one of your buildings you're going to make out of this. You say, horseshit, because I'm a traditional architect and I'm used to dealing with stone, and I don't believe you. And so he has to overcome all that resistance. And one of the most interesting things about the material is that it is the right person comes to talk about it, who's James Taylor, who's a remarkable man. It's the right time for the material, because America is changing in just the right way to need this material. So you think about it, after the Civil War, what's happening in America? You've got people moving to the city in droves. You've got not the invention of the elevator, which we've had forever, but the invention of a reliable elevator brake. So Mr. Otis invents the reliable elevator brake. An elevator is all well and good, but you have to know how to stop it. You've got this huge pressure on the cities to be able to accommodate people. You've got a whole changing lifestyle. And so to do that, you need the right material. You also have, people always talk about the Chicago fire, but there were fires everywhere. We had fires here in New York that were horrendous. I have a statistic. The Boston fire of 1872 consumed 776 buildings and 60 acres of land. Think about that. It's just remarkable. You also have people, America is growing and the cities are growing, and you have people trying to make a fast buck in building. So you have a great fad that's beautiful that comes over from France called the mansard roof. And the mansard roof is a beautiful way to get 2 or 3 more apartments on top of your brick building without using brick. And the results are disastrous. So terracotta comes in, and cities are waking up. Chicago has happened, the Boston fire has happened, New York's a dozen fires have happened. Cities are passing codes that within certain limits, within certain districts, buildings have to be fireproof or as fireproof as possible.
so is terracotta a whole new process that's invented
No.
in the late 19th century? Or
Nope,
did it
it's
have-
rediscovered. Terracotta goes back to ancient times. If the parts of the Parthenon, not Parthenon, I'm sorry, parts of, what's the dome structure in Rome? Pantheon, thank you. Parts of the Pantheon are created using terracotta block. The Romans used terracotta all the time.
Guastavino tile.
Guastavino tile is a form of terracotta. That's
an old process.
That's an old process, but really revolutionary by the brothers, by the Guastavinos.
Right.
It's based on Catalan tradition, and you should really come to the Landmark Lion because we're having it at the Oyster Bar, and you can sit underneath
I
the.
know about that.
Yeah. So yes, all that is terracotta, but the material is ancient. The way we started using it in America is completely revolutionary.
Why
And
is Guastavino tile terracotta and not tile? Is every tile?
every tile is basically terracotta. It's an architectural ceramic. It's just it's a question of terminology.
Oh, so all tile is.
It depends. I mean, some tile is obviously there are stone tiles which are not terracotta,
Like all
and there are
these-
glass tiles.
Like all the Islamic.
But
tiles?
clay tiles, yeah, those are basically a form of terracotta,
Oh, okay.
right? So here it is going together, just wrapping up. So here's an old piece and a new piece, and they really came out quite well. Both of our terracotta manufacturers now have extremely good ability to match glazes and finishes. Just to really quickly go on. So there's the extruded piece. There they are going together. There's a mixture of new and old, kind of a messy job site. That's a weep because we want to let the water back out of the material. There's an old one before cleaning, and you can see they were pretty banged up, but we have always believed that we don't want to restore buildings. We don't want to over-restore buildings so that they become a sort of fiberglass Disney copy of themselves. We want to have the building be the building. So this never became perfect again. It's always had some staining. There they are before the final cleaning. But you can see the old ones going together, and they're doing their job. They're looking beautiful, and they're hiding these ugly, stinky stacks. There they are on a nice winter day. They're great things. And Barbara Zay, who used to work for us, she lived in this building, and we had a lovely evening where we all went up and hung around on it. This is now a deck for the cooperative apartment building where people live, and people can go up and use it. It's great. Like all great amenities in cooperative buildings, nobody ever uses it, so it's always empty. But they're just wonderful things. So this is 36 Gramercy Park East, and I'm running out of time. But you probably know this building. This is an original sketch. We were lucky enough to find the archive. The sketch is backwards, actually, because that's the red brownstone Gramercy building. It should be flipped, but the idea is correct. This is by an architect named James Riley Gordon, who grew up in Texas, came to New York, designed a number of high-style buildings, and then went back to Texas and finished a lot of his work in Austin. And his archive is at the University of Texas at Austin. So that's a sketch from there. This is the building going up, and this is to illustrate, this is correct. So you see the brownstone building to the south of it now. This is to illustrate how easy it is to put this thing up. This building is, without going into too much technical detail, a transitional building. The builders of New York are accepting the concept of a steel frame, but not to support the walls and the floor, only to support the floor. So you can see the side walls have already gone up, and they're brick and stone. They could have been built 100 years before. They're a little taller because they're braced by the steel, but the steel here it's what's called a cage building. The steel here is used only to support the floors, and the terracotta and the brick are laid up so that they support themselves. It's a kind of wonderful mistrust on the part of the people who are designing the building. They say, oh, this steel, it's good, it can do all this work. I love what I've seen in Chicago, I like this, but I want a French Gothic style building, and I'm not gonna support the walls with steel because I don't trust it yet. So instead, it's still comparatively easy to put up, and it's a remarkably ornate building. There we are, sound testing, which is still the best way to understand whether a piece of terracotta is sound or not, whether it's sheared internally, which is the dangerous thing about terracotta. It can have a crack that you don't even see. There's a photograph from the archive, a little bit blurry, but this is one of the little capitals, and this building is a riot of ornament. This is some of the French Gothic detail done. These are the original pattern drawings. So the pattern makers who would make the originals, this is also the Atlantic Terracotta Company in Perth Amboy. They would use these drawings to cut their wood, to cut whatever it was, the plaster that they worked to make the positives, and then the mold makers would come in and make the molds. And if you were to be able to see the hand lettering there, the scale is listed as 26 inches equals 2 feet. And remember we talked about why that is, right? So that's basically 13 inches per foot, right? So here's a close-up of that. And these are all hand-drawn. This is one of the little angels. This building has more little babies on it than any other building I've ever worked on. And as I say, it has babies and they are armed. They all have shields. Someone once told me that this building was built as a commemoration of the Children's Crusade. And I don't know whether that's apocryphal or not. Tom Pike once told me that.
How was it built? What was it built for?
Built for apartments, and it still is apartments. Rental apartments first, and now cooperative.
Well, there is some mythology about why there's a no parking, why they're allowed to have a no parking sign in front of their building.
Oh.
And that's what was it used to be a hotel, but I believe Gramercy Park.
I don't think it was ever a hotel.
Special dispensation.
It's called, in the drawings are called the Gramercy Apartments. So this is that same piece going together.
They're not the only people on Gramercy Park who've done
And then there's a
that.
plaster.
There are other buildings that have done the same thing on Gramercy.
There's a plaster positive. There's that ruler again. There's the piece coming out, and here it is going back into the building. Again, we were called upon. So here you get a good idea. If you look at the picture on the right, you get a good idea of the structure of the terracotta. It's made like a fancy cinder block. It's made with open recesses and what are called webs. The webs help to stiffen the unit. But if you think about it from a drying standpoint and a firing standpoint, nothing is really ever more than about 2 inches thick. So I can get that water out. I can be sure that I have no explosions in my kiln, which is a drag. And I can be sure that the thing doesn't warp significantly in the kiln because I'm keeping the wall thickness relatively thin. So there's some new and old pieces going together. This parapet leaked like a sieve for another sociological reason, which was that when the building was built, let's go back real quick. I think this is fascinating, but then again, I'm a geek. When the building was built, there were, up at the roof level, there were 3 stylized statues of suits of armor. And then 3 more going into the forecourt. You can see them there at the top, the 3 things that stick up into the sky. And between them was a high screen of quatrefoils, so terracotta that made a screen that was probably about as high as the top of those door frames from if you were standing on the roof. And that was okay because when the building was built in 1912, 1913, the idea of living in a penthouse, nobody wanted to do it. That's where you hung your laundry, right? The maid might live up there. But then the whole world changes very quickly. And all of a sudden, the Gershwins come along, and it's the best thing in the world to live in a penthouse, and it's an even better thing to live with a view down to Gramercy Park. If you think about it, you would never do this today. Build a building right next to the fanciest, nicest park, perhaps in North America, and then put up a big screen so you can't see the park. So about 4 or 5 years after this thing was built, they built a really ugly penthouse on top of it out of red brick, and they took down most of the soldiers, except for the ones at the corner, and they took down all of the quatrefoils. So those are all gone. So the original design was such that all of the surfaces of the terracotta that faced the sky, like the head of this little baby, all of them were glazed, relatively impervious to water. But when they took all of those quatrefoils and those soldiers down, all of a sudden they've got all the unglazed bed joints of the terracotta. It's all open to the sky. And that was the beginning. That's when everything started to go to France. So there we are making it, putting it together, and there it is going back together. And so we've done, it used to be that when I first started out in this industry, you had a terracotta project and people would, first of all, we didn't have regular access to terracotta. People were using a lot of replacement materials like cast stone, or cast concrete, basically. And secondly, no one was willing to take the risk of putting a historic piece of terracotta back in the building, because what happens if it cracks in a couple of years? Then they sue me, right? With the work on the Bayard Condit building and some of the stuff that we've done, we have now become more comfortable salvaging and putting back terracotta. So about 70% of the cornice up here are original pieces that were taken out, cleaned, stored in the backyard, and reassembled, because there's nothing wrong with the terracotta. The only thing that's wrong was with the steel behind it and the fact that it leaked. I think, yeah, so here are some new and old pieces going together. So you see the old pieces have all been marked with numbers so they can all go back together, and the orange stuff you see at the background is a modern fabric-coated copper flashing material to make sure that if any water gets in, we take it back out of the wall. I think that's it. So that was really fast. Imagine if I'd done that with 14 more materials.
Do you have some time to take a few questions?
Yeah, I think so. It's just 7 now, so is that all right with everybody?
Please go ahead.
We talk a lot about how it's repetitive and it's labor saving and all that stuff. The other thing to remember when you work on these buildings is even with that, labor was still cheap. So if you think that this rope molding is going to be exactly the same as that rope molding, it probably isn't, because they thought nothing of making another couple of molds because they wanted it to be slightly different. And so the things of the terracotta also coincides with a lot of immigrant labor in America, a lot of very skilled immigrant labor in America. And so you can do this stuff relatively cheaply. I always tell the story about St. Luke's Church up in Hamilton Heights. which was never finished for various political reasons. And it's a Romanesque church, and it's all made out of brownstone. And there are a couple of carved capitals as you go down the main aisle of the church. But there are also these ones that are just blocks that have not been carved yet. And you think to yourself, why would you do that in situ? Why would you go ahead and take all the trouble of putting that thing in and then carving it, carving it up on a ladder, basically? And it's because that was their schedule, and work was cheap. Right? So today, you couldn't imagine doing anything like that. You have that all carefully prefabricated, and it would be lowered into place. But back then, the stone carver was willing to come to the site and get up on a ladder and carve the damn thing. So,
in addition to restoration, is there any modern use?
oh
of
yes,
terracotta?
there's a whole other lecture there, and you can walk around not too far from here, Lower Broadway. There's a new BKSK building that uses an entirely new terracotta facade. There's Annabelle Seldorf building, not too far from Gramercy Park. BKSK also did a nice new south entrance to that terrible tall building that's on Madison Square. So you enter it now from 22nd Street. And it's a beautiful brown and sort of pale cream glazed terracotta facade. And then the other thing that's been very good for the industry is something that's called a Rainscreen. And a Rainscreen are extruded terracotta panels that are hung on a frame, and that's exactly what they sound like.
Because I went on a tour and saw a new building near the Barclays Center in Brooklyn, where it had a ceramic. It looked like individual piece facade, which they said was a German design. And
There are a lot of Germans involved in the Rainscreen business.
but this was the actual facade. It wasn't a rain screen.
No, the Rainscreen is a
This
facade.
sort of looked vaguely like wood almost.
Yeah, some of them do look like that, and they have all sorts of different finishes that they can put
And that would be
on.
considered terracotta.
If it's made out of terracotta, sure.
Well, I mean, it's made out of clay.
Yeah, so then it is. So
Is
it's
there a difference? That's what I'm asking. Is there a difference between terracotta clay and just regular tile?
well, they're all
clay?
there. I mean, you could do, a 6-month course on the difference between, say, ceramics and stoneware and the architectural terracotta of the past, the stuff that we use today, which is slightly different, within ceramic science, there are vast differences. The stuff that we're talking about is a general family of clays, ball clays and marls, the stuff that was readily available to us. That's terracotta as we know
Like
it.
all those, Spanish tile roofs.
That's
those,
similar.
those are not terracotta.
They could be considered terracotta, especially if they're unglazed and red. They're a form of terracotta. It's a very loose term. Right? I mean, it really is. I mean, you could get flower pots that you would consider terracotta. Right? That's what Boston Valley used to make before the Krauss brothers took it over and started making architectural terracotta. They made flower pots.
What's the status currently if I'm living at 75 Livingston in Brooklyn Heights and they have a lot of terracotta? Can I go before the Landmarks Commission and say we'd like to replace this terracotta with another
Something else.
material, like fiberglass? or
Right. Well, if you followed the recent fight about the rules, the rule changes at Landmarks, the Landmark staff was pushing for a greater leeway in substitute materials. We fought back, the Historic Districts Council, among other people, and we basically won that fight. So in order for you to do a substitute material, you'd have to get that approved above the staff level, which means you'd have to make an argument that you can't afford it, or it's more appropriate, it's not visible, all those, the drill. So, the Landmarks law is structured, so you can ask for anything, you can ask for the moon. And if you can present a good enough case, you might get it. But you can't get that at the staff level, with very few exceptions. Does that make sense?
Absolutely.
Yeah, and the reason you can't get that at the staff level is that we fought like hell to prevent that from happening. And we're on the verge. I mean, the public hearing was today, yeah. So, and when I started in the industry, we made pieces of Carnegie Hall out of fiber reinforced polyester. It was miserable.
Really?
Yeah. There's a lot of, do you know if you've ever had a ding in your car and you filled it with body putty or Bondo? A lot of Bondo at Carnegie Hall. It's the dirty little secret.
Do you hold seminars for contractors on this? Because I know when we did the front of our house, our contractor had gone to seminars on brownstone restoration and the history of brownstone.
I don't do that personally, but a very good group of people do.
But I was questioning whether they did it on terracotta because...
They're starting to, and the reason that's happening is, what's happening is the International Masonry Institute, which is both an educational entity and a union, have got the two major terracotta manufacturers together, Gladdy McBean and Boston Valley, and they're putting together seminars and standard details to try and educate contractors about how to use the material, because there have been a lot of people don't understand it anymore.
Yeah,
right?
no, I mean, I think,
so that's happening.
He was really good because when he worked in our house, he said, I've discovered that in fact there's terracotta around the windows, not brownstone.
Sure.
And I bid on this under the assumption that I'd have to replace all the brownstone. And if you want, I'll chip it out and I'll replace it with, brownstone-like detail. But since the terracotta is in good shape, if you'd like, I'll leave the terracotta.
Just leave it alone. Don't touch it.
And he even reduced the price.
So it's a dark red terracotta, right? Does it look like brownstone?
Yeah, it looks like brownstone.
So it's a dark red terracotta, and that's an unglazed terracotta. That's some of the most durable stuff we have.
Yeah, but I was very fortunate because it was all entirely intact. Because
Right.
if it had been chipped or, missing pieces,
A hell of a lot better than brownstone.
then what do you do? But what does the contractor do in that case?
If what? I'm sorry,
If he's bidding on a job that's 90% brownstone.
And some of it's
has a
terracotta.
certain amount of terracotta, and some of the terracotta is missing some pieces, what does he do?
get new pieces of terracotta. That's the best thing to do.
And he can go to, does he have to do it himself, or does he go to?
Well, do you have an architect involved? Then you should.
Why?
Because I need to make a living, lady.
CTA.com.
But then the job wouldn't have been done, because it would have been too
There's
expensive.
repair like that across the street from me on Irving Place. I can see.
There,
And it takes a long time, evidently, to whatever they've measured or whatever the standard.
terracotta takes forever.
Yeah, and so.
That's
you
one of the
think
arguments
that
against
All of
it.
a sudden, there are two buildings, and all of a sudden, I'm gonna wake up and they'll be putting in the missing pieces.
Sure.
that were damaged.
That's the way it works. You do everything first and you wait for the terracotta, and the terracotta shows up and you put it in. There are people who patch terracotta. We do it very, very rarely and only in very limited circumstances. There also used to be a process of blind pinning terracotta, which is terrifying, where you just basically put a steel pin in and walk away and say everything's fine. The Department of Buildings in New York City, to their credit, is now cracking down on that process. Because when you think about it, when there was no terracotta industry in America, the idea of taking out a lion's head, sending it to Buffalo, making a new lion's head, putting a lion's head back, which is the right thing to do, was unthinkable. So yeah, we'll just pin it. And so they would put these screen tubes in, and they were ridiculous repairs. I think we better wrap it up, right?
I think so, too.
All right.
We got some good ideas for preservation school in the spring, though, as well. So,
Thanks, everybody.